Welcome students, we are back with another lesson. In this lesson, we will discuss numerical on lens maker formula. Now before we proceed further, let us revise lens maker formula. In our last class, we have derived this lens maker formula. It states that 1 by image distance minus 1 by object distance u equals to mu2 minus mu1 divided by mu1 times 1 by r1 minus 1 by r2, where r1 and r2 are your radius of curvature. After deriving your lens maker formula, we have applied some special conditions. Now the first condition which we applied was when the object is placed at infinity, as shown in this figure. The object is placed at infinity. If the object is placed at infinity, the image is formed at the focus of this lens. So the image distance V is your focal length. In that case, if we substitute these values here, then we got 1 by f equals to mu2 minus mu1 times 1 by r1 minus 1 by r2. Fine. Now again, after this we have applied another special condition. In this special condition, what we have done is that we have taken your double convex or your biconvex lens and we have placed in a air. This surrounding medium is air, and this surrounding medium, which is air, has a refractive index 1, and we have assumed that this biconvex lens can have any refractive index of value mu. In that case, our lens maker formula can be written as 1 by f equals to mu minus 1 times 1 by r1 minus 1 by r2. Fine. So these are the three equations, first one, second one, and third one. These three equations we have derived in our last class. Now before we proceed further, now look at your equation 3. Fine. Now look at the right hand side part of this equation 3, that is mu2 minus mu1 divided by mu1 times 1 by r1 minus 1 by r2. Fine. Now look at this special case condition formula. Look at the right hand side part again. Mu2 minus mu1 by mu1 and 1 by r1 minus 1 by r2. Now what do you notice in this case is that, look at this right hand side part of both the equations. Right? Now can you see the right hand side part of both the equations are same? Yes. If right hand side part are same, in that case what happens to your left hand side part? This left hand side part will also be equal. In that case, I can write before I write something, let us give this equation some number. Fine. So let us say this is my equation 4. Now look at your equation 3 and your equation 4. So I can write from equation 3 and equation 4, compare the left hand side part. Now since your right hand side part are equal, then what happens to your left hand side part? They are also equal. If they are equal, then I can write down 1 by V minus 1 by u equals to 1 by f. Fine. So this is your this equation is known as your thin lens formula. Fine, so I'll write down here. This is thin lens formula. Fine. Fine. After deriving your thin lens formula, now let us solve some numericals on your lens maker formula. So let's solve your first question. Before this, let's read the question. The radius of curvature of each face of a biconcave lens made of glass of refractive index 1.5 is 30 centimeter. Calculate the focal length of the lens in air. Fine. Okay, so if you read the question, in the question they have mentioned what kind of lens you have, a biconcave lens. Okay, so it's not your double convex lens or your biconvex lens, it is a biconcave lens. Okay, this is your first hint. Now according to the question, they have given the radius of curvature of this biconcave lens is how much? 30 centimeter. Fine. So this is your 30 centimeter. And they have also mentioned that the refractive index of this biconcave lens, which is made of glass, is how much? 1.5. So the refractive index is 1.5. Fine. So in the question, they have given you a biconvex lens. Okay, so let us just draw a rough figure for our understanding. Okay, so this is how your biconvex lens looks. Fine. Let me just move a little bit this side. Okay, now if this is your biconvex lens, fine, they have said that the radius of curvature for this biconvex lens is 30 centimeter. Fine. Now as we know, your lens has two radius of curvature. Okay, so for the first surface, let this one be your center of curvature and this one be your radius of curvature. Fine. Similarly, now for your second surface, this one, let this one be your center of curvature. 1 2 3 1 2 3. Okay, let this be your second center of curvature, C2. In that case, this will be your second radius of curvature. Fine. Now in the question they have only said that the radius of curvature is 30 centimeter, and since this is a biconvex lens, okay, biconvex lens, that means they are made of the same material. If they are made of the same material, in that case the radius of curvature should also be equal. So let me write down. Let us first write down the important points which you have given. So you can write down solution. Fine. Here R1 and R2. Okay, in the question they have mentioned that the radius of curvature is 30 centimeter, but note, okay, for this surface, okay, for this first surface, this radius of curvature is measured in the opposite direction. Fine. If it is measured in the opposite direction, opposite to your direction of the incident of light, fine, in that case what happens according to the sign convention? This radius of curvature will be positive or negative. R1 will be negative, so I'll write down minus 30 centimeter. And in this case, this radius of curvature is measured from left to right along the direction of the incident light. In that case, R2 will be positive. So I'll write down 30 centimeter. Fine. So these are the two radius of curvature. Fine. If you have any confusion with the radius of curvature, please don't hesitate to ask. I will re-explain to you again. Now, apart from your radius of curvature, they have given you the refractive index of this biconcave lens. Now the refractive index they have given is how much? 1.5. So mu equals to 1.5. So using your lens maker formula, okay, now in this case they have not mentioned anything about the object distance or the image distance. In that case I can use this formula, which is 1 by f equals to mu minus 1 by r1 minus 1 by r2. Fine. See, they have not mentioned about what kind of object distance or image distance we have. Okay, so in that case you can use this 1 by f formula. Apart from this, they have said that you have to calculate the focal length in air. If the surrounding medium is what? It is air. If the surrounding medium is air, then I can use the third one, which is your mu minus 1 by r1 minus 1 by r2. Fine. Okay, now let's substitute the values here. Fine. So the refractive index they have given is how much? 1.5 minus 1. Fine. R1 is how much? It is minus 30 centimeter. So I'll write down minus 1 by 30. Fine. Then negative sign, and then R2 is how much? 30 centimeter. So R2 is also 1 by 30 centimeter. Fine, I'll close the bracket. Now what is 1.5 minus 1? It is 0.5. Fine, it is 0.5. 5. And what is minus 1 by 30 minus 1 by 30? Okay, since there is a negative and negative sign, so I can add these two quantities. Fine. So this should give me how much? Minus 2 by 30. Fine. Now this 0.5 also I can write as 1 by 2. Okay, for further simplification, okay, to make the calculation easy, I can write this one as 1 by 2. Fine. Now if you look carefully, this 2 and this 2 can get cancelled. If they get cancelled, in that case I'll cancel this two terms out. What I'm left with? I will be left with minus 30 in the denominator. So I'll write down minus 1 by 30. Fine. So in that case, your focal length 1 by f equals to minus 1 by 30. Now I'll take, now I can either do the cross multiplication or I can take this f to the numerator. If I take the f to the numerator, I have to take this 30 also to the numerator. In that case, my f equals to minus 30. And what is the unit? The unit should be centimeter. Okay, since we are dealing in CGS unit, centimeter gram second. Okay, so in that case, we will use centimeter. Fine. Since we are dealing all of these things in the centimeter scale. Fine. If it was in meters, which is your MKS system, then your focal length will also be in meters. Fine. So how much is the focal length of the lens in air? What is the focal length of this biconcave lens? It is minus 30 centimeter. Fine. Okay. So in this case, what happens? Your radius of curvature and your focal length are of same length. Fine. Now let's move on to our another numerical. Now let's read the question first. A biconvex lens has a focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of the lens material. Fine. Now in this question they are talking about biconvex lens. Okay. So let me draw your biconvex lens first. Fine. Now this is your biconvex lens and this is the principal axis. Fine. Now let's highlight the important points which are given in the question. Now the first important point which is given is that this is your biconvex lens. So I'll highlight this biconvex lens. Fine. Next they have mentioned is that the focal length is 2 by 3 times the radius of curvature. Fine. This is an important detail. It states that the focal length is 2 by 3 times the radius of curvature. Fine. And in this question they have asked you to calculate the refractive index. Okay, you have to find the refractive index. Okay, now again, since they have not mentioned what is the kind of the surrounding medium, okay, so if the question has not mentioned what is the kind of surrounding medium, what you'll assume? The surrounding medium is air. And if it is air, what should be the refractive index? The refractive index of air should be how much? 1. Fine. So this is our first assumption. Fine. Apart from this one, they have said that your convex lens, okay, this convex lens also has two radius of curvature. Okay, so this is your first surface. For this first surface, let us consider 1, 2, 3. This one as your R1. Fine. And for your second surface, let 1, 2, 3. This one be your second radius of curvature R2. Fine. Okay. So this is your biconvex lens. Okay. Now if it is a biconvex lens, okay, look here very carefully. For the first surface, this is your radius of curvature. Now in which direction it is measured? From left to right. Fine. And the incident light direction is also from left to right. In that case, R1 will be positive. Fine. What about R2? R2 is measured from right to left. If R2 is measured from right to left, that means it is opposite to the direction of the incident light. In that case, this R2 will be negative. The radius of curvature for the second surface should be negative. Fine. So I will just write down somewhere. So solution here, your radius of curvature R1. Fine. R1 is positive, whereas your R2 is negative. Fine. Now, since it is made of a single material, both of the lens are of the same material. If they are of the same material, in that case what happens? The radius of curvature should also be same. Fine. In that case, let us assume R1 to be R and R1 will be R and your R2 will be minus R. Okay. This R can be any value. Okay, this is a variable. I've assumed any random variable. Fine. But the only difference is that R1 should be positive and R2 should be negative according to your sign convention. Fine. Now the next important point they have given is that the focal length is 2 by 3 times the radius of curvature. Fine. So if F represents your focal length, in that case, according to the question, the focal length equals to 2 by 3 times R, where R is your radius of curvature. Fine. Now they have given this much details. Fine. They have given this information in the question. Now what they have asked you? They have asked you to calculate the refractive index. Now to calculate your refractive index, again we'll use our lens maker formula. Fine. So using lens maker formula, fine. So Okay, now look here very carefully. Now in this case also they have not mentioned anything about the object distance and image distance. If they have not mentioned anything about the object distance and image distance, in that case I will use this one lens maker formula, 1 by f1. Okay, next they have not mentioned anything about the surrounding medium also. If they have not mentioned anything about the surrounding medium, in that case what you'll assume, the surrounding medium is air. If the surrounding medium is air, then the formula should look like this: mu minus 1. Fine. Next, inside the other bracket I have 1 by r1 minus 1 by r2. Fine. Now here they have given you the focal length. Fine, focal length is 2 by 3r. So let me substitute this value here. Fine. So 1 by, in the bracket let me write down 2 by 3r. Fine, this is your focal length. Now they have asked you to calculate the refractive index. Let us keep this one like this for now inside the bracket. Fine. What about r1 and r2? r1, okay, I have assumed it to be plus r. What about r2? I have assumed it to be minus r. Fine. Now let's start with this one. Okay, here is a negative sign and this is a negative sign. What happens if you have two negative signs? Negative and negative should become positive. So I will have, or I should have, plus here. Fine. Next, see, this is 2 by 3r. Okay, this 3 is in the denominator. Okay, so this 3 should go to the numerator. Fine. So in that case I can write this one as 3 by twice of r. Fine. Fine. Now what is 1 by r plus 1 by r? 1 by r and 1 by r should give you how much? It is 2 by r. Fine. So I'll write down 2 by r here. Fine. Now see, this r and this r are in the denominator and they can get cancelled. So I will simply cancel them out. This r and this denominator r. Okay, if I cancel this denominator r, what am I left with? I'm left with 1. Fine. I have 2 by 1. Now what I will do, I will cross multiply. This 2 will, okay, if I cross multiply, this 2 should go to the denominator and this 1 will go to the numerator. So if this 2 goes to the new denominator, then in that case what you will have, 2 times 2 is 4. Fine. And if this 1 goes to the numerator, 1 times 3 is 3. Fine. So this is 3 by 4 equals to, on the right hand side part I have only mu minus 1. So I'll write down mu minus 1. Fine. Now I can send this minus 1 to the other side. If minus 1 goes to the other side, okay, what it will become? 3 by 4 plus 1 equals to mu. Fine. So, or I can also write mu equals to, what is 3 by 4 plus 1? Okay, you can use the LCM method. Fine. So 3 by 4 plus 1 should give you how much? 3, 4 plus 7 by 4. So this is how much? 7 by 4. Fine. Fine. So 7 by 4 equals to 1.75. So how much is the refractive index of this biconvex lens? It is 1.75. And remember, this refractive index does not has any unit. Okay, refractive index does not has any unit. So our answer will be the refractive index of this biconvex lens is how much? 1.75. Fine. Okay, so I'll do only these two numericals for today. Fine. Now this third numerical you can take as your homework. Fine. You can solve this numerical and submit it to me on WhatsApp. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.